So, hi, good afternoon, everyone. Okay, so uh, apparently there is a schedule change, right? So today will be the last class, right? So in that case, you don't need to present anymore. Okay, so directly uh, go to the Lentera. So in the final project report and code, okay, in June 14, you will submit before this, before June 14. So submit here in the final working software, documentation, and automatic testing. So there is no more presentation. Okay, and then so please include the software code. Okay, if you don't want to put it here, you want to submit it in GitHub. That is better. Okay, uh, and then of course user documentation with UML. Don't forget. Yeah. So I need to be able to run your automatic testing and your code, your working software. Okay. Okay. So based on in that case, the correction is after the last presentation, not the final one, because there is no final presentation. But so we consider the last presentation was the final. Is that okay? Or you want another presentation? If you want. Then we need to have a special schedule. I think. What do you think? So if you don't present anymore, then it's fine. Then I will just base it on the report in your code. Okay? So you just tell me how to open the file. So which file should I open first? So where is the main file that I need to open? So you can rename the file name into main, for example, so that we can, if you have many files, okay, so which one to run? Right. Yeah. Okay. So if test, you just put test, so different file. That is clear. Okay. Okay. So with that administration finished, so let's go back to analysis algorithm. I will not include anymore. So okay. So today we'll discuss our last part. In that case, Numpy we already started last meeting, right? So we can continue that, and then Pandas, and then you will practice simple data analysis. Okay, are you ready? So you can go to this website, Numpy, and then also the Learning Pandas. And then you can open your Jupyter. Yeah? So I will create new notebook. Okay. So this is the one that we discussed last meeting, right? So if you have two array, okay, and then you want to join. Okay, so say you have two arrays, so I put 1 and zeros. Let's do it one by one so that you can see. Okay, this is the one that you make. So I put A, so I put A here. So this, so A is NP1. For example, the size is 3 by 4. So you can see here 3 rows and 4 columns. Can you see it? Okay, and then now I created another matrix P, right? So put P here. This P is 3 rows, okay, and 2 columns. So in that case, I can join side by side. That is called horizontal join. Okay, so we put this way. Yeah? So it's stuck. See? this is the join side by side, yeah? Horizontal stack. Basically, you join two matrices together. Okay. Sometimes you want to concatenate up and down, right? So in that case, of course, the number of columns must be the same. Yeah? If you want to join horizontal stack, the number of rows must be the same, right? Of course. Yeah. You cannot join something that different size. Okay? So now I can create new one, okay? But you can see here the A here is 2 by 2, right? And then B here is 3 by 2. So the number of columns is the same, 2. Okay? So when you do C stack, okay, then you can start to see this. Okay, 1, 1, and 0. Okay, that is how you join. If you have multiple array, not just 2, okay, you can use column stack and row stack. Okay? So this is an example. You have A is an array of 1, 2, 3, 2, right? And then the same thing B and C. Now you can do a column stack here. So this is A, and then the next one is B, and then C. So this is A, 1, 3, 2. Okay? And you see that in the column, this is the first column is A. Yeah? The second column is 5, 6, 4. Right? And then the third column is 7, 9, 8. Clear, yeah? The column stack means you stack the column. Okay. If you do a row stack, okay, of that, what will happen? Yeah. So the first row is actually A. Okay. Okay. The first row is A, and then the second row is now become B, okay. And then the third row is now C. Yes, yes, please. Yeah, you can add 2. Yes, yes. If you use row stack, you can use any number of row. Okay. But if you use horizontal and vertical stack, it's only 2. You want to share your screen? I don't get it. Okay. You can open Jupyter if you want. What do you mean 2 and 4? I don't. Maybe you can explain using your example. Okay. Say the first. Okay, you want to share your screen? Okay. Go up. There. Yes. Okay. You can try. You can try. Okay, you can try. So, say you have A and B. Okay, so try that. You can open your Jupyter. The nice thing about programming is you can instantly try. Yeah. If you're not sure, you can just try on your own. Right? So any other science, you need to do some experiment. For example, biology experiment, say you do agriculture. If you try that, okay, you will get the result maybe 3 months later or 1 year later. Okay? But in physics, probably you will try and then you do set up an experiment, and then what you will do, you will try. It's quite a long time to check the result, right? But in computer, it's kind of instant, so you just try directly in your laptop. Okay. So if you have, Kenneth was asking. So if we have A, so this is A, right? And then this is B. And then what do you want to ask? 5 and 6 only, without 4, you mean? So let's do that. So let's call this D. Okay, sorry. Let's call this new array. Let's call it D. Okay, and then D has only 2 elements. Is that so? Okay. 5, 6, you put comma like this. Yeah, you can try. So okay, so if you check D, okay, you have only 2 elements, right? And then say you said, oh, can I do a row stack? This one again with, instead of B, now I put it D here. Right? Is it working? You can try. It's not working. Why it's not working? Yeah, because basically inside Numpy, they do concatenate. So okay, when they do concatenate, the number of dimension must be the same. Right? So either the row or the column must be the same. So in this case, it's not the same, so it's not working. Right. Okay. So, right. So if you have, if you know how to add 2 matrix or 2 array together, horizontally or vertically, now sometimes you also want to know if you can split that matrix. Right? So you have a matrix table. Matrix is basically a table, right? If you have a table, now you want to split it. Okay. Let's create that. Okay. So let's create that new matrix. Okay, so let's name this A. So this is a new matrix, 0 to 23, right? And then you can use split of that matrix, and then you can use location and then the axis. Yeah? So if you split over row, then you set axis 0. If you split over column, okay, then you use axis 1. Location here is the location where you want to split it. Okay, so here example I put NP split of A. Yeah? So you can start with this. Okay, so for example 2. Can you see? That means you split that matrix. So 0, 1, 2. Right? So this is up to here. And then the rest is another matrix. So you create 2 array. Okay, two matrix. Okay, let's name this B, C equal, right? And then you can do like this, and then I will get only the B, and then I can get the C here. Okay, so you can see I split that into two matrix. Okay, and I keep name to that two matrix. Is it clear or not? So that this matrix, this is the location where you split it. Yeah? This axis means you split it over the column. Okay. You can also split it this way, right? So I put 2,5, right? And if you do like this, what will happen? I created three matrices. Yeah? Three matrices. You see array, array, array. Yeah, because you split at position 2 and at position 5. Yeah? So this is position 0, 1, 2 here. So, and then 3, 4, 5 here. Yeah? So at position 5, you also split again. Right? So then you have three matrices. In that case, the result will be, you can name it C, D, E, right? It's no longer 2 because your result is 3. Okay, so if you do like this, what will happen? Error, yeah? You understand? Why? Because the result is 3, not 2. Okay, so you need to do exactly the same between your input and the output. Okay. Oops. This is the automatic. So then you can do the C, still the same. Okay, and then now you can change into D. Okay, this is the D, and this is the D. Right? Okay, and separate. Okay, so now you can also do the same thing. Okay. Let's do it 1 and 2 here, but the axis is 0. Okay, let's do this. Axis is 0. Let's see what is C in here. So because axis is 0, so you get this, right? And then what is D? Yeah, D is this one. Yeah? Okay, on horizontal. Yeah. And then, of course, the E is the last one. Okay, so that last two rows. Okay, yeah. So I hope this is clear. So the meaning of axis here, where you split over column or you split over row. Okay. Yes. You can try. You can try. So what happened if we split over 0 here, right? Okay, so if you put 0, the location 0, you get empty matrix. Okay, the location must be, this is the 1, 2, 3, 4. Okay. So you can try. So 1 and 4, example. And let's see E. Again, this is empty. Yeah? And if you look at D, here is the 3 of them. Yeah? And if you get C, C is 1. Sorry, E. C. C is the first one because the split is here. Okay, so if you make a mistake, it will become empty array. Okay. So the nice thing in Python is, look, every time you want to do, you just try this. okay, with certain number, and then you get the result, okay, and then is this the one that you want? Okay, if this is not the one that you want, then you can change that splitting value, okay, and then you check, oh yes, this is what you want, then it's finished. Okay. Okay, so what else? Is there any question? So far so good. Okay. So we have this finish and numpy. Okay, transpose is just rotate. Yeah? So the row become column, column become row. Right? Yes. So let's try this A. So oh, a while ago we already create A, right? Okay, I will just print it again. A. Okay, so this is A. Can you see? Okay. So if you want to do A transpose, you just dot T. A transpose. So there. Can you see? So the row now become column. The second row, yeah, now become second column. Can you see that? Yeah. So in linear algebra, you always use this. Splitting. Okay. So one of the most probably important operation in linear algebra is matrix multiplication. Okay. So if you have matrix multiplication, I will draw in the screen on the whiteboard. So if you have matrix A and you have multiply with matrix B, okay, equal to matrix C. Can you see my whiteboard? Okay. So important here is the size. Okay. So the size, say matrix A is M by N. Yeah? Okay. So in that case, matrix B must be N by P. Okay. Okay. And then matrix C will be M by P. Okay. So what does it mean? Okay. Is that right? So the number of internal, the row and the column must be the same. Is that correct? So because every row you will multiply by its column. So the number of row in matrix A must be the same as number of columns in matrix B. Oh, I think this is it. I think this is reverse, right? Okay, let's try. Okay, so say I have matrix A. Okay, this is matrix A. What is the size of matrix A? 4 rows and 6 columns. Right. Yeah. This is 1, 2, 3, 4. Okay. And let's name this matrix B equal to A transpose. Huh? Oh, okay. Okay, so this is matrix A. Can you see? The one that we make a while ago. Okay, let's make a matrix B with this A transpose, right? Okay, so here. So the size of matrix A is this one I put here. Size is 4 by 6. 4 rows, 6 columns. Okay. is the matrix P, the size is 6 row, 4 column. Correct? Oh, okay. So question, can I multiply A times B? Let's multiply. Yeah. So to do multiplication, you just do this one, NP dot. Yeah. So what you will do is NP dot A multiplied by B. Okay. So the result is 4 by 4. Right. So 4. Okay, this column must be the same as the number of rows. The number of columns in matrix A must be the same as number of rows in matrix B. Okay, and then the result will be the number of row in matrix A and the number of columns in matrix B. Yeah? So in this case, become 4 by 4. Okay. Clear or not? Clear, yeah. So now can we multiply B with A? Yes. Okay, let's try. Okay. Okay, so we can multiply B with A. Okay. So you get that. What is the size? Now becomes 6 by 6. Okay. So size matter. Okay. If you make a mistake in size, it will not generate correctly. And because B in this case is A transpose, okay. So then this is always so basically this is the same as A transpose, right? Correct. So this always become symmetric matrix. Yeah? This one is always become symmetric matrix. What is symmetric matrix? You see the diagonal is something, but the upper triangular here is the same as the bottom. Yeah. So here is 145. Here is also 145. 235. Here 235. Right. And you see, this is symmetric. Yeah. As if there is a mirror yeah, in the diagonal. Okay, the same thing here. Yeah? So this is always symmetric. Why? Because this is B is actually A transpose. Yeah? So run. Yeah. So anything multiplied by its transpose will become symmetric matrix. Yeah. So now I will do what is called forbidden multiplication. Yeah. So we cannot multiply if the size is incorrect. Yeah. Let's do this. Okay. So what is the size of this? A transpose now become, you know, the size is 4 by 4. Right. Okay. Let's name this G. Is that okay? So that you will know G size is 4 by 4. And then let's name this 8, okay? Which size is actually 6 by 6, right? So you 6 by 6, okay? Okay, now I want to do G times 8. Can I do that? I'll try. Can I do that? No. Why? Yeah, it's not the same. Okay, so this must be error. Okay, okay, so uh, why this is error? Yeah, so G, okay, multiply. I will put it into yeah, G multiply by 8, right? But this is the problem is the G is actually 4 by 4. Okay, multiply by 6 by 6. Yeah? So you see this one, this number of columns in the first matrix is not the same as the number of rows in the second matrix. That's why it's error. Okay, so if this is this must be the same. Yeah? This the number of columns in the first matrix, okay, and the number of rows in the second matrix must be the same. So let's try. Let's create. Okay. Let's create similar like this. Okay. Let's create matrix 8 now. You want to have 4x. Okay, so let's do 8 in here so that you can see, and I will draw G so that you can see. Okay, so this is G. Okay, so this is 4 by 4, and I have another one 8 with is, okay, I will delete this one so that you will not get confused. Okay, so G8 is how much? 4 by 6. Yeah, can I multiply? Yeah? Can I multiply? Okay, so G and H. G and H, right? So what is the size? G is 4 by 4, right? So this one is 4 by 4 multiplied by the other one is 4 by 6. It must be okay, right? So there it gives you a result with this. The size, the result is 4 by 6. Yeah, the first row, the first matrix row multiplied by the second matrix column. Is that okay or not? Okay. Now, can I reverse? Can I reverse? Can I multiply 8 by G? Yes or no? No, no, right? So it will create error. Huh? Okay, you see, huh? So why? Again, because the size, okay, is not matching. Yeah. Okay, so this is the size is 4 by 6, right? And then multiply by this is 4 by 4. Yeah? So this is not the same. Yeah? 6 and 4 not the same, so cannot multiply. So then what is your conclusion? Apparently matrix multiplication is not commutative. Yeah? A times B is not the same as B times A. Yeah. Why? Because size matters. Okay, clear or not? Okay, good. So there. So now you can add. Okay, if you have the same size of matrix, you can add, you can subtract. Okay, let's say I have. Let's create the same size of matrix. Is that okay? Okay, so G is 4 by 4. Oh, the earlier A. Let me see. Okay, let me get a new. This one I delete. Okay, so that I can show. Okay, A. What is the size of A? Okay, so this is 4 by 6, and then the one that 4 by 6 is 8. Right? Is that right? Okay. So 8. 8 is again the same, yeah, 4 by 6. Yeah? Okay, anyway, it's the same value. So can I add A plus 8? Oh, plus 2. Yeah. So let's keep f equal to a plus 8. Oh, in Numpy, okay, matrix addition is just that. Okay. So you just put as if exactly the same. Ooh, I got the matrix addition. Nice. Okay. Okay. So you treat matrix as if just number. Okay, very nice, isn't it? Okay. So the same thing. Okay, you can have so k equal to a minus 8. So what we will get here? You will get, because a is equal to 8, so k must be 0, right? Cool. Yeah. So with this, you do linear algebra as if, it's a matrix, but you don't care about matrix. Matrix is just like number. Okay. Very nice. Very nice. Yeah. You don't need to program it. Yeah. You just do like calculator. Yeah. Calculator. Just the normal. Yeah. You can also add. Okay. So instead of that, you can also add. So k equal to k plus 1. What will happen? I will print the k. Oh, all 1. Okay. So let's call a again. Yeah. A is like this, right? So I can add. Okay. A equal to a plus, how many you want? Plus 5. Okay. Okay. Check. Okay. Let's put it. Oh, let's name it differently. Okay. Let's name it L so that you will see. This is not A, so L. Oh, you see 0 plus 5, yeah, 1 plus 5. So addition with scalar, you can just add. As if this is just normal number. Okay, matrix is now become, you don't care about matrix anymore. You can just do it as if normal number. Isn't it nice? Okay, so increment, decrement, yeah. And you can also do function. Okay, so you can do log, for example, sine, cosine, yeah, square root, exponent, and so on. The same thing, yeah. So in here, so I just log, for example, sine. Yeah. So this is L, right? So I just put sine of L. Okay. There. Wow. Wow. That means every element you do sine. So you treat, okay, matrix, okay, as if they are number. Okay, is it nice or not? So when you that means you don't care the size. Okay, for example, L, okay, is this one is 4 by 6, right? But I have a while ago G. What is that? Oh, this one. Okay. So let's name this Z equal to, so that you will see this is what is the size of Z. So this is again this is 4 by 6. Anyway, so again if I do sine of Z. You can see one by one, yeah? It will be computed automatically. The size, now you don't care. Okay, when you do a function, okay, it doesn't matter. Okay, you care when you multiply because the size matters. Okay, but when you do function, okay, you don't care about the size. Okay, so yeah, square root, the same thing. Yeah. So suppose you have your own function. Okay. The Numpy have already sum, mean, maximum standard deviation, and so on, right? So this is already inside. Okay. So you just sum like this, mean and standard deviation. But say you have you want to sum or you want to do mean, okay, you want to do the mean for not the element, okay, but along one axis. Okay, so this one. So what you will do, this is your z a while ago. I will show again. Okay, this is your z, right? So then what you will do is there is NP, okay, apply along axis. You want to take the mean, okay, of axis 0, mean row, right? So the array is the z, okay. What you will get, oh, yeah. So you will get the average of this. Okay, maybe I will show A so that you can see clearly, and along axis of A, so maybe this is easier to read. Oh, you see, this is the 1, 2, 3, 4, 5, 6, right? So every column here, okay, this is the mean for each column. Yeah? So if you do axis 1, what you will get? Every row. You see, you have only 4. 1, 2, 3, 4, right? This is the mean for each row. Oh, so if you don't want mean, you want to do sum, you can also do that. Yeah? Just get the sum. Yeah. Correct, yeah? 1 plus 2 plus 3 plus 4 plus 5 is 15, right? Okay? So now if you put axis 0, okay, so 36, what is that? 0 plus 6 plus 12 plus 18. Nice, nice. Yeah, you can do along what certain axis. Yeah, either row or columns. Okay, you can just do the sum or mean or standard deviation. Good. Yeah. With that, I hope you enjoy Numpy. There are so many other function in Numpy. Okay, these are like the basic one, so you can also enjoy a lot of other function. Almost all linear algebra, for example, eigenvalue, you can also do. Okay, so let's create square matrix. Eigenvalue must be square matrix, right? Okay, let's make a square matrix. So how to make a square matrix? To make a square matrix, okay, I will just multiply A with A transpose. Oh, sorry. Oh, dot, dot, dot. Where's the command dot a while ago? Ah, here. Okay, let's do this. So this is the one that we have. I copy again. Okay. Anything multiplied by itself is a symmetric matrix. So symmetric must be square matrix. Yeah? Square matrix means the number of row is the same as the number of column. Yeah? Okay. So because this is square matrix, there is an eigenvalue and eigenvector. Okay. E comma V equal to, yeah, NP 8. Oh, let me check. I cannot remember. NP eigenvalues, eigenvector. Oh, there. Oh, must be linac. Okay, so there is a component. So NP linac 8. Okay, so linac 8 of G. Okay, it will create eigenvalue and eigenvector. Okay. So of course this is a complex number. Okay. So when you learn linear algebra later, this is like one of the bases. Yeah? So you need to create use eigenvalue, eigenvector later. Okay, I don't know about this. Okay, no problem. At least you know there is code for it, so you can use. Okay. I have a linear algebra tutorial anyway in my website in Rekonedu. So if you want, you can also there anything you want to ask about NumPy? No. Good. How about those who are online? Eh? Matthew, Tarin,
No, sir.
Tamara. Oh, is that Sia is. Where is she? Suddenly, I thought she already in Surabaya. Oh, okay, so let's go to the next one, Panda. So this is kind of database. Okay, so let's do Pandas. So I delete this, I create a new Python notebook. Okay, you can also create new Python notebook. Can you see my screen with a Python notebook? Okay, good. Okay, so and go to this website. It's from Lantera. You can go here, right? In the old days, there are three main data structure in Pandas, but now it's only two, so only series and data frame. Okay, panel is no longer there. Okay, so if you want to do Pandas, you can just import Pandas as PD. Okay, here I'm using everything. So this one, this is matplotlib is to plotting. Yeah. So to do plotting, let's go to the website of matplotlib so that you can see. Okay, so this is for visualization. Okay, I don't discuss it here, but you can check by yourself in the examples. Okay, you can plot any type of chart. Okay, very cool, yeah? Including contour. Yeah? So and all you need to do is just go to this website and then copy and paste. Right? Yeah? Very nice. Okay. Okay. Learning Python is very nice. All you need to do is to go to that website and copy and paste. Yeah. Let's try. Okay, let's try. Okay. So they have very good documentation. So all you need to do is copy and paste. Ta-da! Oh, error. What is the error? Okay, I have no users. There. So I get that. Okay. So if there's an error, yeah, maybe this is the style, yeah. This is the new one. My Python is probably old one, so it does not have this one. Anyway. Okay. So again, you can have many different plot, including quiver. This is the vector movement. Okay. Say you want to do magnetic field, yeah, or electrical field, right? Okay. So you can plot. Physics. Your physics. Okay. Okay. So very nice. So you can try on your own. Okay. All you need to do is just copy and paste. Okay. If you update it, so probably this is working. If not, you just remove this line. Okay. So Panda, let's go to Panda. Okay. So Panda have two main data structure. One is called series. The other one is data panel. So series is basically array. Okay. And data panel is basically a table. Okay. So one-dimensional array is called series in Panda. Okay. And then a table, 2D table is called data frame. Okay, if more than 2D, so 3D is called panel. But okay, now they remove, okay, to simplify. Okay, so unlike the usual array, right? Unlike the usual array, say if you create this, for example, yeah, this is called list comprehension, right? So let's delete this. Okay, I start again. So if you do like this, well, this is the Python array, right? This is Python array. This is the usual Python array. Okay, so you can check the type. Type of file is a list, meaning this is Python array. Okay, so in Pandas, you can create, okay, an index of that array. So I give example. So let's create another array called index. Okay, so I create another array. So etx. Okay. This is just an index, so 0 to 9. If you don't like it, you can just put +1. Oh, sorry. edx. Oh, because this is Python, so not NumPy, so you cannot just add with 1, right? Okay. Okay. So anyway, so you can put this one is 1 to 11, so that you can get. Okay. So 1 to 10. Okay. So then what happened is you can create a Panda series. Yeah? Okay. So look at this now. So I create a Panda series. So I give name S, right? Oh, Panda is not defined. Oh yeah, I did not define. So you just copy. Okay, so I need to define PD because okay, there. Okay, the value is this one, right? 1, 4, 7 until 28. Okay, now I created a kind of table, right? But this is not table; it's a series. Okay, okay, it's an array with an index. Okay, so this is the index that I put there. Okay, that index can be number, can be string. Okay, it's up to you to decide the index. So then you can start to call. Yeah, you can start to call. For example, here I create a new one. That index is no longer number. Let's give a name, not S here. Let's name it S1 so that I make it different. So this is a series of 4 array, right? But the index is now I can give different name. Okay, ZQCF. Okay. If you don't like, I can call it Billy, New Field, yeah. Yeah. New Field. Is that correct? Yes. Okay, Kenneth, yeah. And Joy. Okay. Okay, so this is an example, right? So you create a series with an index. The index is the one that you put there. Okay, so what's the name? S1, right? So then I can put S1 Billy is 15. You hear that? Yeah. So you can call, okay, based on the index. Okay. So the same thing S a while ago, the index is like this, right? So then you can say S, okay, S of 3 is 7. Is that correct? S 3 is 7. Oh yeah. you get the value, okay, based on the index. So this is similar to dictionary. Yeah. So series is basically similar to dictionary. But if you use dictionary, if you want to sort, it's hard to sort, right? But using pandas, okay, there are a lot of functions there, okay, that you can directly say you can sort the values, okay, like this. Okay. You can sort descending or ascending order. Okay, so in this case, S1, right? So S1 is 15 minus 3, 9, and 6. So when I sort the values, oh, it's reversed. Yeah? Can you see? A while ago, earlier, Billy is number 1. Okay, but now because I sort the value, okay, Neufil with minus 3 here is now become the first one. Okay, so now you can also do ascending force. That means you do descending. Okay, so what happened? Okay, is reversed. The value is sorted based on that. So you get that. So now you can manipulate the data easier. Yeah? Panda is for data analysis. Yeah? So data science and so on always usually use Panda as the base. Okay. So and then if you want to sort not the values but you want to sort the index, okay, you can also do like this. Yeah? So you sort the index. Let's try. Okay, so a while ago the name is S1, right? So you can sort index there. Okay, so because based on the index, so B, J, K, yeah, N. That is the sorting based on the alphabet. Clear. Okay. Okay. So, and then of course you can relabel. Yeah? If you don't like, you can relabel the index. So all you need to do is just the same again. Create that one, and then the index is the new index. Clear, yeah? Another method to reindex is you just do reindex. So S reindex. It's the same thing. Yeah. So Panda. Okay. So reindex will change the order of sequence. Yeah. Delete some of them or add new one. Yeah? In case it is a new label, right? So you reindex, but actually the number of index is larger than the value, and Panda will automatically, gracefully, add none. Yeah? Here, this is an example. Okay? Panda will add none to the not value. Okay, so in this example a while ago, okay, S1 you can do reindex. Okay, so let's do S. Okay, so then the index now you can create. Sorry. So let's give a new name. Okay, say A. I give name B, right, and then C, and then D. S. Oh, what is the value? This one. Okay, so let's call it S2. So you can see now I have another one, okay, but the index is now changed. Okay. Okay, so Yeah, of course you can access. Yeah, you can access based on the index. Okay. Oh, nice thing. Okay, let's go to here. The value is 15 minus 3, 9, right? And then 6. Okay. Now I can check S2 that is larger than 5. Okay. It will give you a number 1. Yeah. 15 is larger than 5. Yes. Yeah. 3 is larger than 5. No, right? False. Yeah. This is the index. 9 is larger than 5. True. Yeah. And 6 is larger than 5. True. Yeah. So this is a kind of mass. Okay. So I will put like this. Okay. So I call this mass. Yeah. Mass is this one, right? So now let's do S2 and mass. Oh, what happened? I create a new one based on that mass, but it's only the true value I will create it. Oh, nice, right? Okay, so you can do Boolean. Hey, you learned already Boolean last semester, right? Okay, logic. Okay, so creating the logic. What is that for? Again, you create the mass. Okay, so true, false, and then you use that. Okay, then you can create new data. Is it nice or not? So you can select, yeah, you can select only the data that specify based on your criteria, right? The mass is the one that you set, yeah, larger than 5. So this criteria that you set. Okay, or you don't like larger than 5, you can make it less than 5. Okay, so to the mass, so it's reverse, right? And then if you do like this, it will get only the minus 3. Okay, depending on your criteria, you can create new data. So is this something useful? Yes, very, yeah. So of course you can check the index and the values. Okay, so if you want to get only the index, okay, so S2 index, that means you only get the index. Yeah. Okay. The same thing if you put S2. This is your value. Values. Yeah. Or whatever. The automatic is. Oh, so that is the value, right? So is this clear? Yes. So if you want to remove, yeah, some part of the series, okay, you can use drop. Yeah. Or say I create a new one, S here. Oh, where is my S? This is my S. Okay. And then I do S drop. This is my S is 1447 something, right? A while ago. And then what I do is S2 index. This one. Oh, there is no X2 index. X2 value now. Values. Okay. You drop mean you remove. Yeah? Oh, there is an error. Why? Because this is not axis in that axis. Yeah. So if you want to remove, you need to remove something that is already here. So I can remove, for example, okay, let's do that. So let's remove the last two. Okay. Let's drop 25 and 28. Not found in the axis. Let's drop 9 and 10. Oh, there. Okay, so the drop here means this is the name of the index, not the value. Yeah. Correct, yeah? Yeah. So based on the index is the one that you drop. Yeah. So now when you sum two series, okay, so I have S1 plus S2. Let me check. What is my S1? Oh, this is my S1 and this is S2. Okay, this is my S2. Okay, what happens if I have S1 plus S2? Oh, okay, I got only the, I only get the index. Yeah? The value cannot be summed because there is no overlapping. Right. So what happens if I have S1 plus S1? Okay. Earlier 15, right? Minus 3, 9 and 6. Now, yeah, now become 30 minus 6, 18 and 12. Okay. So this is double. Okay. So if there is no proper index, it will become none. Yeah. The one that is with proper index, that is the one that you add. Yeah. So if you have like this, okay, you can remove the none. Yeah. So if you want to remove the none, you just put drop none. Okay. So for example, this is your series. Okay, you can drop none, and then you get only the correct value. So later on when you do data analysis, you will use like this. Yeah. So sometimes you do some analysis and get an A. Okay, then you can remove that NA. Okay. So another possibility to remove the none from the data is to check, yeah, not null. This will produce Boolean. Yeah? And then once you, what is this? Boolean always the mask, yeah, masking. So then you put that into this, like this, yeah, inside the index, then automatically remove. Yeah? Okay, so only the true value in that mask is the one that produced. Okay, so up to here, is there any question? Is it clear? Huh? Really? Yes. Okay, so if you want to remove certain data based on the index, yeah, you can also use drop. Yeah? So say you drop certain index, say index 7, index 11, so you can just drop. Yeah? See, so this is the Pandas series. Yeah? So it's similar to dictionary and list, but okay, you can do more analysis. Yeah? Clear, yeah? Now, the next type is called data frame. Yeah? This is basically two-dimensional data, similar to matrix, yeah? Okay, or database table. Yeah, so they call it data frame. Three main attributes, again the same, index, values, right? But now you have columns. Okay, let's create first. Okay, let's create first. So I have this value. If you create this, you will have exactly the same, 1, 4, 7, and so on. And this is the index, right? And a while ago we have the series. Yeah. Okay, let's create a new one. So this one I don't use, so I delete. Oh wait, I need to put pandas, right? Because this is new, I need to put import pandas. Pandas as PD. Yeah. So I got the S, this S in here. Yeah, this is the because this is the value and this is the index, so I have index is from 0 up to 9, and these are the value 1, 4, 7, and so on. So I create a new one, and then I can create what is called to frame. That means from series to frame. Yeah. So usually we call it data frame DF. Okay. Oh, now I create 2D. Yeah. And you see the difference. Series is usually this way. They Panda is using in data frame. You create a table. Okay. Can you see? Uh, I have my new uh, notebook. Okay, and then we start with pandas import, and then we created the same as before. So this is the exact copy of earlier. So this is the series. Yeah. So the index is 0 up to 9, and then the value is 1 to 28. Okay, and we can create from series to data frame. Yeah? Series is just an array or dictionary. Okay, data frame is basically a table. Okay, because you have only one column, so let's give a name value. If you don't like, you can name anything. Yeah? So here you can see we have a table with only one column. Okay, that column name is that file. Is it clear? Okay, good. And let's do the type. Okay, so the type of DF is actually a data frame of Panda. Okay, so you see, it's a data frame object. Okay. Okay. Now let's do a NumPy. Okay. Now let's combine pandas with NumPy. Yeah? Let's import NumPy as NP, right? And then let's create NP arrange this shape. Do you understand the meaning of this, right? Already. Yeah, so we create a NumPy arrange, okay, of 1 to 100 with skip of 4, right? And then you reshape it into size of 5 by 5. Okay, so well, you can rename this of A. Okay, so A is basically the 5 by 5 matrix. Okay, and because this is NumPy, so you can check the shape with this 5 by 5. Okay, now suppose yeah, I want to create a table. Okay. Let's say this is actually a strength, elasticity, and so on. Yeah, so this is, say I create a column name of my data. So column. Oops. Whatever. Okay, so this one. Okay, so this is column is just an array. Okay, and then what I will do, I want to create a table, okay, with this column, because this is 1, 2, 3, 4, 5, right? And this is also 5 column. Yeah, correct, right? So that A I will create into data frame, yeah, 5 columns, and then the column name is strength, elasticity, diameter, longitude. So this is, I just make it up, yeah. Okay, so what you will do, you will create df. Okay, so we will create that df. Now I create a new df with this based on A, right? And then column. So df, is it working? Oh, it works. Okay, so it's a problem. Why? Because why is it not in column? Okay, because when you put like this become index. Okay, so if you want to do like this, you need to put columns. Then it become correct. Clear? Okay, so okay, so if you put the columns of that df, is of course come back to this index. Yeah. So if you ask how many columns, yeah, so length. Yeah? Okay, and what is the index? Oh, let's check the index of df. Yeah. Okay. In df index, so df index. Oh, the df index is a range between 0 to 4. Correct? So starting is 0, stop is 5. Why? Because 5 is exclusive. Okay. Start is 1. Okay. So, yeah. Now, if you want to get the value, if you want to get that value, this is the index, right? The index is here, 0, 1, 2, 3, 4. Okay. And if you want to get that value, so you just put values again. Okay. Oh, you get back the Numpy a while ago, yeah. The internal value of the table. Okay, nice. So you can get the index, you can get the columns, you can get the table, yeah, out of data frame. Okay. So yeah, you can reindex if you want. Yeah. So say for example, I create a new one. Yeah. So yeah, if you want to change the index. Anyway, so say you have a dictionary now. Okay. You have a dictionary. So I create new one. This is called dictionary tick one. Yeah. Tick one. So it's a dictionary. Okay, so this is a dictionary. Okay, now I can directly from dictionary to Panda data frame. Yeah? So color now become column. Yeah? Fruits is the second column. Yeah? These are the values. Okay, clear? Okay, let's try that. Yeah? So I create TF2. Yeah, because these are 1, 2, 3, right? So arrange 1 to 4, that's okay. You can see that. You can create a table with nice format already, right? So okay, based on pandas. Of course, now you can select. Okay, so to select, you can just put the name, okay, and then the column. Yeah? So, for example, what is the name is here? TF2. Yeah? So TF2 color. There. The color TF2 is red, green, yellow. Yeah? So you can get the whole color. Yeah? the same thing. What is the name here? Taste, right? So let's try TF2 taste. Yeah, crunchy sweet sour. Okay, you can get the whole column. Okay, another way, of course, oh, instead of dot, okay, I can do like this, the same thing. Yeah? TF2. Okay, now you can name it taste. You will get exactly the same. So when do you use this? When the name is actually contains space or something, right? You need to put with quote. Yeah? So if the name is no space, then the column name has no space, you can directly use dot. Right? Clear, yeah? So now I don't know this is still working or not. Let's try. This is very old one, so let's try. Oh, it's no longer working. Yeah, I told you it's no longer working. Yeah. Now there is no EX. Okay, let's try what is EX now. The old one is using EX, so I think now it's using lock or something. Pandas EX. Oh, there is an okay lock, right? So no. Pandas EX replacement is, I think the name is lock. Yeah. iLock. Lock or iLock. Okay, so you just change that. Yeah? So instead of EX, now you can put as lock or iLock. There. Okay, so that means what is this? This is the first column, right? 0 means the first column of this table. Yeah? Color. Yeah. So using this, instead of if you don't know the column name, okay, you can use index. Yeah? 0, 1, 2. Yeah? So let's try. Fruit is supposed to be the first. Yeah? This is 0, 1, right? So let's try that. Okay. So remember this column notation means all. Yeah? All rows. Yeah? So 1. Yes, apple, banana, cherry. Is that correct? Yes, apple, banana, cherry. Okay, so you can use that way. Because this is open source, right, and community development. Okay, so sometimes there is some suggestion from the community, then they change. Okay? So the new version, okay, will no longer be the same as the old one. So when this tutorial was made, I think it's 2017 maybe. Yeah, 2017. Okay, now 5 years later, some is no longer working. Right? So that's why they said sometimes, okay, that if you are away from computer, okay, say you go to the jungle for 2 years, okay, okay, then suddenly some of your code is no longer working. So you need to keep updated with the new one. Okay. That is the one that make the programmer expensive, you know, right? Because their knowledge must be keep updating. Yeah? Unlike other engineering, so once you learn, then it's finished, right? But this is not. So you need to keep updating yourself. Okay, how about this? Okay, so instead of 2, okay, so how about if we reverse, yeah? The iLog, right? So the same thing here, but we reverse the dot. Okay, so this is 1. Oh, what's that mean? Yeah, you will get 1 row. Yeah, it is the first row. Yeah? this one. Is that correct? You get green banana long sweet. Green banana long sweet. Because this is row 0, this is row 1, and row 3. Yeah. Again, ilog is based on the standard indexing. Yeah. 0 is the beginning. Is this clear or not? So how about if I want to get not one row, not one column, but one particular cell in the table? How to get that? Say I want to get only the banana. Anyone knows? So you can use the same thing. Yeah? So you can use ilog, for example. Okay, 1, 1. That I get banana. Right. Oh, I don't want using that index. I want to use fruits. So you can use that. Okay, TF2 fruits. Is that right? So this is fruit, right? Now, if you use this, be careful, yeah. If you use this, what you will do? I want to get the banana. So 1. Oh, 1 is apple. Yeah. Banana is number 2. Okay. Indeed, because you are not using ilog, okay, what you use is actually the index. Clear? Okay. If you use the variable name directly, not using ilog, so be careful, you are using index. Yeah? If you're using ilog, you based on the 0, 1, 2, 3. So, yeah? So, is this clear, the difference? Okay, so you know that. Huh? Next, okay, so you can also do slicing. Wow, this is it's called OLAP operation. Eh? So online analytical processing. Eh? So you can do slicing like this. Eh? So okay, so similar to ilog directly, you can do 0 to 2. Again, this is exclusive. Okay, so you can get only partial of the table. So remember, the whole df2 is something like this, right? Up to 3. So if you said 0 to 2, that means only the first 2. Okay. Oh, this one. Okay, this is again ix now become ilog. Don't forget. Okay. So ilog. Oh. How about log? Okay. If you use no, now become log. Okay. So if you want to get only the first and third row, okay, then you use log. Okay, so once you can extract the information from the table, now you want to change that table value, isn't it? Right? That is called assignment. Okay, so to do assignment, okay, so for example, df2 test 2, let me check. Okay, this is sweet, right? So remember df2, I will show again, yeah. So when I said df2 test 2 is this one, yeah, test, and then the index is 2, right? So now I want to change that, okay. Yeah, df2 is now no longer sweet, yeah. The green banana, what is the taste of green banana? No, it's already sweet, but I want to change that sweet. What is the taste of banana aside from sweet? Oh, you don't like banana? Okay. Huh? Okay, delicious. Delicious. Okay. Delicious. Okay. There. Let's check the F2 again. Oh, there. It changed, right? Now you know how to change. Okay. You specify the cell, you can change that. All right. Okay. So the same thing, yeah. Oh, now you can also assign a new column. Okay. So I create here, yeah. DF2 demand equal 20. Okay, let's try that. Is it still working? Oh, still work. Okay. No error. Right? Okay. There. Okay. So I create a new column with a certain value that I assign initially. Right. Oh, isn't that nice? You just type one command like this. Of course, this is only 3 rows, yeah. But imagine that you have 1 million rows, right? And then you just type this one and then immediately fill up 1 million. So nice, right? Okay. And because you have only 3, okay, so you can actually fill up, yeah. So instead of 20, I can fill up. Okay, the demand is 15, 10, and 30. Yeah, you can fill up that. So you can see the TF2 now become 15, 10, and 30. Yes, you can just put as a list. Okay, the value that you put as a list automatically sent into that column. Oh, now you can manipulate, yeah, your table. Yeah, you know how to extract. You know how to assign. Okay. Ah, the one that makes the table useful is actually filtering, isn't it? Masking. Okay. So say I want to do a demand that larger than 10. Oh, of course, 15, 10, 30 larger than 10 is the first one and the third one, right? Okay. So if you want to know how many times that one, so you just do the sum, right? So that one 2. Yeah? How many true? 2. This is the total of true. Okay. And now because you do masking, so you can exactly the same thing. Yeah. So I will create this. I call this mask equal. Okay. So let me show you again the mask. Okay. Now I can do like this. TF2 of mask. I can get the one that you want. But at this time, you get the row that is true. It's not just the demand, you can get everything. Okay, now you can filter the whole table based on certain criteria that you assign. Very nice. Okay, this is what data analysis is about, isn't it? You do filtering. Yeah? Oh, say I have sales data. Okay, can I get only the sales that is actually most profitable in the last 3 months? What is this? This is filtering. Yeah? Based on the date, right? Okay, and then after that you take the statistic of that. The top one. So these are filtering. Yeah. You can also see. Okay, I want to see if the taste is sour. Yeah? So I want to see. Okay, in my table when the taste is sour. Only one in my case. Oh, that is cherry. Okay, so you can check that. Okay, next is in. Yeah, is a membership function. Okay, so Yes. Yeah, of course you can add row too. Okay, so you can just add. Is there any? This is delete, merge. Okay, I did not. So, you can just add row. Very good question. Yeah, pandas add row. At the end of the different, you want? Okay, so then df log. Okay, so yeah, so you put this one length of the index, right? And then what is the value? Okay? So you can also use another way. Okay? A new line. You can also concat actually. So say you have a new line, okay, and then you can concat, or you can append. Okay, so there are many possibilities. So okay, easy. Panda, basically you can do. Important here is actually you know how to do masking, filtering, because this is the most useful things that you are doing in your data analysis. Okay? Suppose I want to do this. Okay? I want to get masking here that is round and profile. Okay, so let's check here. Let's do a masking 2. So df2, this is right, and there are 2 rounds in the profile. Okay, so let's do the mask 1. Okay, now you see the one that is round in profile, this is the only true, correct? The others all false. Can you see that? Yeah. And then, of course, based on that, you can do TF2 mask. This will create an error, a lot of none. Okay. Right? But you get that already. See, this round, the one that you get. Okay. So after that, what you will do, you can drop. Yeah? Drop none. So drop none. Is that so? Oh, it removed everything. Oh no. So yeah, so sometimes you want to delete certain cell, right? So if you say demand 1, this one, right? And then you delete, you set it as none. Yeah? NP none is the one that you delete. Yeah? Certain cell that you want to delete, that is mean you set it as none. Okay. If you want to delete one column, so del df of the column name, say you delete the demand. Okay. If you want to delete the row, you drop that index. Yeah. Say drop row 3, right? So you get that, or you can drop certain index more than 1, so 1 and 2, you get only the 3. Yeah. So what happened is this is the same as database. Okay? The next one is merging. This is a little bit difficult. So in database you can join several tables into one table. Okay, so there are 4 types, yeah, of merging. Okay, one is called left join, right join, outer join, and then inner join. Yeah? So in SQL, if you're using SQL, these are the command in SQL. Okay, in Pandas, you also have exactly the same. Okay, so let's do this. Yeah, so you try this. I have a two table. Okay, let's do this. This is called left table. Left. Okay, this is left table, and then let's create another one called right table. Okay, so there are different number of rows and different column. Can you see? Key A, B, here is key C, D. But the key, some of the key are the same. Some, not all. Some of the key are the same. So of course cannot be all, because you see this one have 6 rows and here is only 4 rows, right? So some of the key is the same. Then you can join them based on that key. Okay, so let's try. Say you want to merge. Okay, what happens if you join them? Okay, we merge left and right based on that key. Okay, and now you see the result. Yeah? Oh, now I have K0, K4, K3, K3, K0, K3, K3, K4. Yeah? And earlier we have only A, B, right? And then this one only C, D, right? And then what you will have, now I have got the whole thing. Right? I can join the whole table together, but based on the key. The key must be the same. Question? So, on table, yes. Yeah. Yeah. In the table, you need to create a key. Okay. In database, usually you always create a key. The key is the one that you use to join two tables. Okay. So now what happened is, yeah, this is also in the, if you use these two, yeah, so this is how is the inner join. Yeah? Remember we have left, right, outer, inner. Yeah? So what is inner? Inner means you use the intersection of the key from both frames. Okay. Outer join means you union the key for both frames. Okay. So if you should use right, mean you use the key from the right frame only. Okay. Left means you use the key from the left frame only. So how do you join depending on the key that you set and how the method. Yeah. So say let's try that. Okay, we use this, but how? Let's try using right join. Okay, so right result. So I get exactly the same as before, but now instead of right, let's do it left so that you can see the difference. Yeah? Left have how many key? How many rows? Okay, so if you use the left key, right? This is the left key. K0, K1, K2, K3, K4, K5, right? So you see here, I got K0, K1, K2, but K3 is double, okay? And then K4 and K5. Yeah? So why? Because in the right, yeah, K3 is also tuple. So it repeated based on that. Good, right? But some of these are not having data, right? K1 does not have CD. Then it will automatically create none there. Okay, yeah? Is this clear or not? Yeah. So the same thing, yeah. You can use outer join. Okay. So now the K5, yeah, now you combine the whole key, yeah, as union. Okay. Now the K5 is not exist, so you get none. Okay. I hope this is clear. Yeah. I put it there. So you can also do merging based on more than one key. Okay, so you can put on key 1 and key 2. So of course, your call you need to have the same name, yeah, for the key. Must be the same name. Yeah? So key 1 and key 2. Okay, so here is in this example, you have this is key 1 and this is key 2. And again in the second table, right? This is left and this is right. You have 2 again, key 1 and key 2. Okay, and then now you combine, okay, inner join. Yeah? This is if you don't do anything with how, that means inner join. Yeah? So inner join means you get the intersection of the key. Yeah? In this case, because you have two keys, so intersection of the two keys. This is the same, so included. Yeah. How about this one? This is not the same, then this is not included. Only the one that the same is included because inner join mean intersection. Yeah. Outer join mean union. Okay. So yeah, this is the outer join. Yeah. So you create a union. Okay. Now you have a new key which is in here exists on the right side but not exists in the left side. So in that case, A, B is become none. Okay, so next you can also plot. Okay, so say I created new data frame again here. Okay. Again, all you need to do is just copy and paste here. Oh, okay. It's not working because I did not import the matplotlib. There. Oh, nice, yeah. So what is this? I created a new data frame based on this dictionary, right? A, B, C, D. Yeah? And then I plot. Yeah? Plot is just copy and paste, and then I can also created the summary of that, yeah? Mean, total, and so on. And then you can plot the table. Okay, you can plot the table, and then you just show. Right? Nice. With this, we are ready to do a data analysis. Yeah. Right. Yeah. Statistic. Yeah. So you can make a report in statistic using Python. Yeah? Okay. You can try this. The next one. Yeah. You can also use into HTML. Okay. You can also change the, say if you use this definition, you can also change the color of the table. You see. Yeah. Or you can highlight also. So you can do formatting basically, yeah, to show certain style that you want. Okay. All of these are just styling. Okay, clear. You can make it. Yeah. Okay, so next one, the one that I want you to do, homework. Last homework. Oh. Okay, last homework. Okay, so I give you here sample data. Okay, and I give you also the website. Can you see? Okay, so this is a simple data analysis using Python. Okay, but if you just use the website, there is no data, right? So I give you the data. Okay, so the data is here. Yeah? So your homework is just do exactly like this. Okay? Yeah? Just copy and paste and try to understand. Yeah? Okay. So in here we do, these are the steps of data analysis. Yeah. First you need to get the data. Okay. After that you need to get the lookup table. LUT means lookup table. Okay. So data, the actual data, okay, you need to put it into lookup table. Okay. And then that lookup table is the one that, for example, if I put object 1 in here, that means apple. You got it? If I put object 2 in here, that means banana. Yeah? The same thing, yeah? If color 1 here is green and so on. So, and then from there you can replace, yeah, to do converting that data table into the one with the value. Okay. After that, you want to remove the NA. Yeah? Okay. So you can do a cleaning. Okay. Based on your data, you can do cleaning. Okay. So replace, yeah, the one that put, and then this is called feature engineering. What is that? Meaning you create a new feature. You need to create a new variable. Yeah? So if your data is very big, okay, Panda, look, I use other software, like for example MATLAB. Okay, I have million of data, and to open the file only, if you use MATLAB, probably around 6 hours. 6 hours just to open the data because it's very big. But I use Panda, 2 seconds. Okay, the difference between 6 hours and 2 seconds. So you can see the power of Python. Yeah? So how to do that is this one. This is very important. Okay, yeah? Low memory fast. Okay, so then you can read the CSV file. Okay, even very big, you can use for big data. Okay, so again you can merge because now you have 2 tables, right? Look at this: fruit, color, price, and then this is object, color, price, right? And then now you want to combine, okay, with the count, right? So you can merge them. Yeah? After that you can sort, yeah, and then now you can calculate the revenue, the profit, right? Okay, so and then you want to do the sum because you want to know the actual revenue without none. Okay, then you can use none sum and so on. Okay, so and then you need to do the basic analysis of any data is analysis of its variable. Yeah, so that means you do distribution. Okay, and then you check the plotting, and then box plot is to check the anomaly. And then you do 2 variables. Yeah? This is called crosstalk. In Pandas, it's just copy and paste like this. And pivot table. Okay, this is the assignment. Last assignment. Thank you very much for today. Yeah. So see you next semester then. Okay. Okay. Yeah. So the exam is in Lentera, multiple choice, as the same as midterm. The material, the coverage from the beginning until the end. Yes. Yes, yes. Before midterm also included. From the very first until the end. Okay. The date is already there, right? When is the midterm? Oh, 17 June. Yeah, 9 to 11. Okay, so you still need to send your final. Okay, so if 17 June, maybe around 19 June, I will put here in the last part here the Excel file of your entire grade. Okay. Check yeah, between 19 up to 25. Yeah. Okay. Between 19 to 25, I will put the Excel file here, the computation of your grade. Yeah. If you protest, you can protest at that time. After you, if you don't protest until say the deadline, 25, for example, and what happened, I will just input that into the system. Then you, even if you cry, oh, give me a better grade, no, okay. Because I already put here. So, say for example, you did not submit certain things, okay? Those who did not submit, so you still have chance to submit. Okay. Okay, so I don't want anyone to left behind, so please do submit all your assignment. Okay, thank you very much. And thank you for the semester also. Bye.
Thank you, sir.
Thank you, sir.
Yes.